Welcome to the video lecture series on principles of compiler design. This is Dr.K.N.Sivabalan and we'll be learning about recursive descent parsing today. So recursive descent parsing is one of the top-down parsing techniques where we will actually apply some mutually recursive procedures to implement the grammar. And we'll be stepping inside this recursive descent parsing in an elaborate way. So first we will learn about what is recursive descent parsing and then we'll go for how to implement that. Now the recursive descent parsing is called as a top-down parsing technique. Generally it is actually implemented by recursive procedures, but the major constraint is when a grammar is having a left recursive grammar, then we cannot apply this parsing. So we have to eliminate left recursion. So we have to eliminate left recursion and then we can apply recursive descent parsing. That means this grammar left recursion cannot be applied, but a right recursive grammar can be applied in recursive descent parsing. And if an input is a non-terminal, then the corresponding procedure should be implemented or corresponding procedure should be called. For instance, if you have a non-terminal called as s, then you have to create a function called as s, and then the subsequent actions has to be done in that function. For all non-terminals which is existing, say for example, if a grammar is having three non-terminals, then all these three non-terminals should have respective procedures or respective functions. That means it should have three functions for implementation. And if the input is terminal, then compare it with the corresponding input stream. And if it is the same, then we have to advance the input pointer to the next element, so on and so forth. This should be continued in this fashion. So only major key point which we have to note here is if we are using a non-terminal, then the corresponding procedure has to be called or it has to be created. And if we are meeting out with the terminal, then we have to advance to the input pointer. We have to advance the input pointer to the next element. And if a non-terminal is having more than one production, so all the corresponding actions has to be brought in one procedure here. And these are the key points which is pertaining to recursive descent parsing. Now in this case, I have taken an example for s tends to as dash and s dash tends to star as dash epsilon. Now since s is called as a non-terminal, we create a procedure called as s. We create a procedure for s, and when we move on the right, we encounter a terminal here. The terminal symbol is called as a. So if input of I is equal to a, then if it matches, then we actually advance the pointer here, I plus plus. That means we are advancing to the next element. And then after this a, we actually encounter s dash here. Okay. So I simply make it as s dash because you cannot use s dash symbol here. So instead of that, I have written that as s dash here. Now this is the way of actually implementing the first grammar, s tends to as dash. Now we will go for the second one. When we go for the second one, s dash tends to star a s dash par epsilon. Now since we are seeing s dash, we create a procedure called as s dash here. Now when we step inside, when we move on the right, we encounter a terminal called as star. So if input of I is equal to star, okay. Now we advance the pointer one time, so I plus plus. Once we advance it, again we encounter a terminal called as a. So if input of I is equal to a, if it is a terminal, then we have to match it, then advance it. So this is the procedure. So now we are advancing again I plus plus. Now after this a, we actually encounter a symbol called as s dash. S dash is a non-terminal, so simply call the procedure called as s dash. Okay. Now if s dash can also have another grammar, if none of the symbols meet out, if we are not meeting with a star, then obviously it is epsilon. So we go to else part and simply make return. So epsilon is nothing, so we are actually returning that. So this procedure is called as s dash. Now we will go for the main program. So main program is here. So we actually declare two variables as global variables. One is called as I another is called as an input array. So these two variables are actually global variables, and then when we enter the string, so using the gets input function, when we enter the string, so immediately we call yes. Yes is called as a starting symbol here. Yes is called as a starting symbol. I call the starting symbol procedure. So now finally every input string will be ending with the dollar symbol. So dollar is actually called as a delimiter which denotes the end of the string. So if input of I ends with the dollar, that means that is called as an end of the string, and then that is called as a parsing successful. So if it does not meet out with dollar, or if you are not actually intervening during this intervening point, if you are getting any other symbol which is not in the grammar, obviously it will report an error. So I am simply making it as printf error. So since in main is called as a controller function, it has to return integer value. So simply I am returning 0. So if you directly execute this procedure, any string which is of a star a of this format will get executed. Now we will have a graphical depiction of this recursive descent parsing, and we will take up we will understand how to take a valid string. Now here in this case, yes is called as a starting symbol. Yes can be abbreviated as AS dash, and this S dash can be abbreviated as star A S dash, and S dash can also end with epsilon. So I am not actually recursively applying multiple times, I am applying just only one time. So when you read this tree from left to right, you can see here we are only reading the terminals here. When you read the terminals, you will get A star A. So A star A is called as a valid string, and finally A star A should end with dollar. So that is called as the end of the string. So this is how a graphical representation of the string can be understood. So we can apply this string, this is called as a valid string, and obviously this has to be recognized with the code which we have already written in the previous slides. So thanks for watching the video. Have a good day.